All right, let's talk about one of the most fascinating tools in the entire AI world, the autoencoder. Now, on the surface, it just looks like a fancy copy machine. But as you're about to see what it can actually do, well, it goes way, way beyond just making a copy.
And that really is the big question, isn't it? How can a piece of AI whose only job is to copy its input to its output turn out to be so ridiculously powerful and useful? It sounds kind of backwards, I know, but the secret behind it is absolutely brilliant. You see, it turns out it's not the copy that matters. The real magic isn't in the final product. It's all about the process of making that copy. The autoencoder is forced to learn the absolute essence of the data, and that's what unlocks all these incredible abilities.
So at its core, an autoencoder is just a neural network trained to do one thing: make its output look exactly like its input. But here's the clever part. There's a bottleneck in the middle. Imagine trying to explain an entire movie to a friend, but you can only use 5 words. You'd have to pick the most important words, right? That's what the autoencoder does. It squeezes the data through a tiny space, forcing it to learn a super compressed, super efficient summary. That's where all the magic happens. And this whole process gives autoencoders some serious superpowers. For one, they're amazing at data compression, obviously. They're also fantastic at automatically figuring out the most important features in a bunch of data. And, as we're about to see, they make for incredible detectives when it comes to spotting anything unusual. So, let's kick things off with their first big talent. This is all about not just understanding data, but being able to rebuild it and even create totally new data from scratch. It's about seeing, and it's about creating. Okay, one of the most mind-blowing applications is image denoising. Get this, you don't give the autoencoder a nice, clean picture. Instead, you throw a messy, noisy, corrupted version at it and tell it, your job is to show me the original, clean version. It literally has to learn how to see through all the static to find the real pattern underneath. And wow, just look at this in action. On the one side, you have these handwritten numbers that are so staticky you can barely even tell what they are. The autoencoder takes that mess as its input and boom, look at the output. It's almost perfect. It has learned the idea of each number so well that it can just ignore the junk and rebuild the clean version from its memory. It's incredible. But it gets even crazier because it understands the fundamental patterns so deeply. Like, what makes the number 2 actually look like a 2? It can basically run the whole process in reverse. It can start from nothing and generate brand new, totally realistic, handwritten numbers that have never existed before. It goes from being a cleaner to being a creator. So, this amazing ability to know what's normal leads us straight to its next big skill: finding things that are not normal. This is where the autoencoder puts on its detective hat and gets to work, finding clues. Think about it like this. Say you train an autoencoder on millions of pictures of perfect, brand new products rolling off an assembly line. It gets really, really good at copying perfect products. So what happens when a broken one comes down the line? The autoencoder looks at it and basically says, whoa, hold on, I've never seen anything like this before. It totally fails to make a good copy because broken just isn't in its vocabulary. And that failure, that's the whole point. The huge mistake it makes trying to copy the broken item is like a giant flashing red light. It's the system's way of screaming, hey, something here is different. This makes it a powerhouse for things like finding fraudulent credit card transactions, spotting hackers in a network, or, catching that defective product on the assembly line. It's literally flagging the deviation from the norm. So we've seen them clean, create, and detect. Pretty impressive stuff. Now, let's look at some really high-level, real-world tasks where this technology is an absolute game changer. We're talking about huge impacts in fields that are completely different from each other, like facial recognition, cutting-edge medical imaging, and even how computers are learning to understand the way we talk. For facial recognition, it's the same idea we've been talking about. You train an autoencoder on a massive library of faces, and it learns to boil down each person's face into its most essential unique features, a kind of compact facial fingerprint. That becomes the core engine that powers a ton of recognition systems. Now, in medicine, the impact is just profound. There's a souped-up version called a variational autoencoder. It doesn't just learn to copy, it learns the underlying probabilities of the data. This lets it do incredible things, like model how a disease might progress over time, or even predict how a specific patient will respond to a treatment. It's a massive step toward truly personalized medicine.
And finally, we have natural language processing, or NLP. Autoencoders are a key piece of the puzzle in getting computers to actually understand us. By learning meaningful representations of words and sentences, they help machines process language much more effectively. This is the tech that powers everything from translation services to the chatbots we talk to every day.
So just think about that journey. We started with what seemed like a simple copy machine, and we ended up with the technology that can restore images, hunt for criminals, recognize our faces, model diseases, and understand our language. It's just an amazing reminder that sometimes the most powerful ideas are born from the simplest concepts. The real question is, as these AI artists and detectives get even smarter, what hidden patterns in our world are they going to uncover next? Thanks for tuning in.